this. I'm okay.
Well, what they probe us? Actually, I've never figured out what probe means. Do they put cameras in your eyes or what?
You would have to ask that question right when I hit record. They're talking about parts of your body that you would want things to be placed in.
Oh, okay.
That would be the best way I could describe it. Now, why somebody came up with that, I don't know. But like I said, I'd be more worried that, you know, if all of a sudden we found that grasshoppers tasted like chocolate, would we think twice before we ate grasshoppers? Or we would like just chase them down and eat them? I fear for us that one day aliens will come and they're like, oh, humans taste like chocolate. In our defense, I would say that we believe that we don't eat thinking animals, like animals that can, like we, you know, even some of the more we think dogs think, right? And so we would frown upon someone who ate dogs, right?
But cows can think.
What do they think about?
Grass.
Which is why we eat them. But if all of a sudden cows started, I don't know, showing affection towards human beings, you know, we probably might rethink our consumption of beef. That's my personal opinion.
No wonder dogs are so friendly. They're like, please don't eat.
Agreed. There's that symbiotic relationship right there is, we believe is, you know, one of the reasons why that they do that. It's because it's a mechanism that perpetuates their species of, oh, now humans will take care of it. And think about it. What does a dog actually do?
Nothing.
Right. We feed it. We clothe it. If we put clothes on it, we take care of it. I mean, it does provide a, you know, guard dog, right? You know, that sort of thing. Back in the day, or even today, we still use dogs for herding and whatnot. But the term working dog is very loosely labeled to, like, I mean, I own a working dog, but that's its breed, you know, or I don't know if we call it King of Final Class or none of that part, but it's in the working dog family. But my dog does no work. You know? How do we get started on this? What?
I don't know.
Well, you did some of the ones. 8 was the hardest one, you know.
Is this wrong or we wrong?
Oh, I'm sorry. No, this was not your homework. This was not your homework. This is the class. I didn't make a class for you guys today. I'm just using the other class. So your homework was not this. What was it?
It was.
Okay, that's right. That's right. Okay, any questions? Yeah?
Hi.
17 and 18? The last two?
Oh, I never got 8.
Oh, gotcha.
9,
Last two
please.
columns. Which one, Ben?
9.
9?
9.
9.
No.
That's German for 9.
No.
9 is no, and 9 is number 9.
Do we have a quiz sometime this week?
I believe we have a test on Friday.
Okay.
That's not Friday. Why am I in the wrong chapter? Now I'm on the right thing. Okay, last two columns. So we're told the measure of each interior angle, I'm just doing one of them, is 78. 70 or 178? 178. So 178 is equal to the measure of one interior angle, okay? So we need to find number of sides, and we need to find the measure of one exterior angle. I don't know if I did this in order, but that's what we're doing. Okay. So measure of one interior angle. Do we have a formula for measure of one interior angle?
Isn't it n minus 2 times 180 or 4 minus 2?
That gives you the sum of all of them, but what about 1?
Divided.
Divided by n, right? So we get n minus 2 times 180, all divided by n. Well, we're told it equals 178. You just got to solve that for n. Okay, so algebraically, what would I do?
1 the distributive property.
Okay, we can do that. All right, so 180 minus 360 over n. I left off an n here somewhere. N equals 178. Now what?
You add 360.
Yeah, it's not 360 though.
Oh, you times 4 to the number.
4?
No, n. No, not n. You come
N.
up. Yeah.
Let's multiply both sides by n. I probably would have done that first step, but that's fine. Multiply both sides by n. Well, the n's would cancel, and you'd be left with 180n minus 360 equals 178n. Check out that math right there.
Well, you just add those two numbers
No,
together.
no, no, they're on opposite sides of the equal sign.
No, but you have to add them together and put the 360 on the other side.
I'll agree with the 360. We're not going to add these two.
Oh, you're gonna subtract them.
Yeah, we're going to subtract them, so we would get 2n. McKinley said add 360, so we get 360. Can you follow those two steps in your head real quick? What I did right there?
So that's what you.
And
Yeah, but I mean, do you follow the algebra what I just did? Okay. Yeah, so n equals, that's weird. It's a polygon with 180 sides.
There is no poly. Wait, yes, no, wait, there is.
There's an infinite number of sides, right? That's a circle, by the way. Now we got to find the measure of one exterior. What's the formula?
N times, no wait, n minus 2 times 180. Not
That's
two.
interior.
Oh,
You
it's
look at exterior.
60 divided
And I know that n is 180, so therefore
by
it's 2. That's weird. I mean, that's a really, really, really tiny angle. That's because it's got 180 sides, right? It's got 180 sides. So any one of those, I mean, it's practically a circle, but these are, this part, if I extend this line right here, that angle right there is 2 degrees.
So that's how you
And
solve
that's
this
why
part.
it's got 180 sides to it.
I did none of
All right.
this right.
So that's how you do no, that's how you solve the last two.
No, I mean, I didn't get any of those answers right. I was thinking that was different.
What was the other one?
9. 10,
Number 9, it says you have a baseball home plate. If you didn't know already, it's a hexagon or a pentagon?
I think it's a quadrigon. Pentagon.
Yeah, it is a pentagon. So pentagon. Okay, so there's home plate. Has 3 right angles. So what are the possible 3 right angles? Go ahead.
One in that corner,
Yeah.
one in the other corner,
Yeah.
and one at the very
If
corner.
this has been a right angle, then it would go across like that. So it's got to be this one, right?
Yeah.
So that one's right. There's your 3 right angles. The other 2 are congruent. So it means that that is equal to that.
So they must equal 90.
What is the shape?
Pentagon.
Okay.
Pentagon.
So what is the sum of all the interior angles of a pentagon?
That is 36. No, wait, that's 540.
540, and you know how many right now?
Yes, 90.
How many do you know?
3.
I know 3 of them, they're all 90, so that would be 270. Plus this one and this one. Now, if I call this one x, what's that one? Because since they're congruent.
X.
So plus 2x equals, what does it equal? You just calculated it.
540.
540, can you solve that?
No, I don't know.
Can you do that in your head? So x equals,
207. No, wait, 207.
do you recognize that 270 is half of 540?
Yes,
So if we subtract a 270,
you get 270.
and therefore half of that is 135. 135.
But they can't be the 135. They're both smaller.
Well, I drew them pretty crummy, right? 135 is
Yes, they are.
clearly
They're
a,
smaller than 90 degrees. Look, if you take.
you're talking about this angle right here is smaller than 90?
Yes. From the way the drawing looks, it looks like a acute angle.
They look obtuse to me.
They look acute to me.
Acute would be smaller than 90. Here's 90. So acute would be even smaller. This is going this direction.
But it's going inwards on that.
We're talking about this angle. Right there. It's definitely obtuse. Maybe I didn't draw 135, but I don't know, let's see what I drew. Where did I draw? I drew 140 degrees. So that was pretty close. All right. Good? Yeah.
I have one more.
What?
18.
18. What is the measure of each interior angle of a regular pentagon?
It would
Right.
be
So what's the formula?
And minus 2.
all divided by n, because it says one angle, right? So a pentagon has 5. We kind of just did this one, right? So it would be what? 540 divided by how many sides? 540 is the sum of all the angles, and it says how big is one of a regular one is where all the angles are the same, not like a home plate. So it's that perfect looking pentagon. So how many sides? Pentagon. So it's 540 divided by 5, whatever that is, 108. Is that right?
Can't do that.
So that's part A. And then it says the following. Can you tile a floor with tiles shaped like regular pentagons?
Sure.
Okay, so when you tile a floor, do you want any open spots?
Yes. Yes. The little outside areas of every single
Like this floor, do you want the carpet to cover all the floor or part of the floor?
part of the floor, all the floor.
I think all the floor is what ours. So could you carpet this floor with rectangles?
Yes.
Could you carpet this floor with squares?
Yes.
Could you carpet this floor with hexagons?
No.
You'd have to cut a couple of the hexagons, but would the hexagons perfectly match up to each other?
Yes, if you get
It
it
would.
tightly in.
This is a process called, you may have heard of it or not, called tessellation. Tessellation is where you can cover an entire surface with shapes and there's no empty spots. So it turns out with a pentagon, there's a picture of the book, by the way. If you open up the book to the very next question, they show you what? They show you,
A possible and impossible shape.
right, so they're showing you that and this is a soccer ball made up of pentagons and hexagons laid flat would not tessellate, right? But if you curve it around, this is kind of an extended question number 18. It turns out that 18b, you can certainly tessellate it with hexagons, but you can't with pentagons. So pentagons would never work. And the reason being is you end up with this big open space. And that's also why a soccer ball is made up of a combination of pentagons and hexagons. All right, so B is hard to wrap your head around.
So that
All right.
means I could tile the floor with human faces shaped.
Like hexagons.
No, like
Um,
like circles.
I'll show you. These are called Sierpinski diagrams, if I remember correctly. Just please let good, clean pictures show up when I do this. Do not have naked pictures. All right, Sierpinski. I believe it's spelled Sierpinski. I think that's right. Yes, Sierpinski carpet. All right. Wikipedia safe. So Sierpinski carpets are carpets that are made up of the same shape that's just repeated over and over and over again. There's a lot of math in this, and they make a very pleasing shape. I think a Sierpinski diagram is what I'm looking for. Diagram.
But how is it that complicated? I could make a bunch of tiny shapes and not know a single thing about it.
Yeah, so these are all Sierpinskis. Hey, look, you can make shapes with triangles and whatnot. Yeah. They're related to fractals as well, too. Okay. Back to homework. All right, so here's what we got going on today. So I don't think it's necessary that I actually do this for your class. However, we're going to do it anyway. So I'm doing this for my regular class. At times, we reach a level of things that you need to do in geometry. I mean, like skills. Like, by the way, once we proved the theorem, we didn't do anything with polygons and their measurements, right? We just said, now let's just do a whole bunch of weird calculations. So eventually we get these, quite a few of these calculation type ideas. We don't really practice it that much. So today is just a practice day. So let's back up a second. Let's think about what we've done this chapter. Do you remember how the chapter started?
Yes, we started out with lines.
And the lines were
Congruent.
parallel to each other, cut by a third of transversal, and we got like, what, 3 or 4 different congruent pair, I'm sorry, 3 or 4 different pairs of angles that had names to them. Then we were able to say something about each one of those. And then the next thing we did was we jumped to triangle, and we got a formulas for that for exterior angle and the sum of the two remote ones. And then we finished up with polygons, interior, exterior angles as well too. So I'm just saying we've done enough that we might want to take a pause and just do a bunch of practice problems just to make sure that all those concepts are solidly in our head. For an honors class, occasionally I do this. For a regular class, I always do this. And so I just thought it was probably worthwhile that we just try it this year. Usually, like, the last 2 years that I taught, we were so far behind. Like we started in September, I didn't have any extra time, and so I didn't do a lot of review days. Now I have a whole month, since we started a month earlier, of days that I can use for review days, and so I'm choosing to use 2 of them. Long story short, we're going to review in this chapter, not proof, not logic, but we're going to review some of the things that we've done, and just I will show you what the questions on the test will kind of look like for the calculation ones. All right, so your homework tonight's going to be a packet. It's got a lot of questions. I mean, I want to say it's got like 60 questions on it. I wanted to put enough on it, and I'm going to give you the answer to every one. I wanted to give you enough so that you would, if there's one thing that you're weak on, that you didn't just have like 1 or 2 problems, you had, like 15 of them, so that you could get a lot of practice on one concept. If it's a concept that you look at it and you're like, I already know this one, I don't need any more practice, well, then skip it. Move on to the ones that you need practice on.
So it's like the review test.
It is, because I'm also going to give you all the answers as well too. So unlike a normal homework where you kind of struggle with yourself, well, this you're not going to struggle on. But I also wanted to have enough so it was a real honest to God practice day. All right. So we're going to do 2 days of this. Today we'll do angles formed by congruent lines, and then tomorrow we'll do the exterior triangle theorem, or exterior angle theorem of a triangle. I'll take that a second. And then we'll do the polygon things one more time to fully lock this into our head. All right, here we go. So we've been dealing with this basic construction. Here's the basic construction. You have 2 lines, H and K. They're parallel to each other, and they're cut by a third line, T, the transversal. Transversal is a line. It doesn't have to cut parallel lines, but it's just a third line that cuts the given 2. All right, we end up getting a bunch of constructions. So McKinley, you give me a name, and then Anna will come up with the so what.
Oh, interior angles.
So what?
So they
And then you also got to give me an example in the picture. So alternate interior angles, that's one of the constructions we get. So what? Alternate, what did he say?
Oh, interior.
Alt interior. So 1 and 6 are not alternate interior. 3 and 6 are alternate interior. So what? They're congruent. That's the so what. That's the game we're playing. All right, you're on. So what? They're congruent. We did prove that. You're not going to see that on a test, but we did prove that. All right, your turn. Same side interior.
3 and 5, or is it?
Yeah, it's 3 and 5.
Okay, and 4 and 6.
So what?
They're parallel. No, they're the exact. They're the same side interiors.
So what?
They exist.
So what?
I don't know.
Well, the other ones we said they're congruent. Is 3 the same as 5?
Yes, they're congruent.
Because look at the picture. This one's acute and this one's obtuse. So that ain't true.
Oh, so they make a right angle. Keep in mind together.
They do not.
They make an angle.
They do.
They make a big angle.
Yes, it is a big angle. They're supplementary. They're supplementary. So these are the things that you got to have off the top of your head. All right. From the previous chapters, I can think of 2 more things we can say about this picture. Can you think of anything else you could say from previous? It's chapter 1 and chapter 2. 1 and 4 are vertical. So what? All right. Can you think of anything else? There's one more that I can think of. So we got all the ones from this chapter. Chapter 2, we had vertical angles, and we need to have one thing from chapter 1 that we could say. And it dealt with postulate 4.
Aha, they equal each other. They equal some number of an angle.
It's true.
It's like 90. No, not 90. They
Well, can you
equal
tell
a
about 1 and
measurement.
2? So we have that from chapter 1. So two adjacent angles that make a straight line, we call them linear pair, right? They equal 180. So we get those basic statements. There's a last one I chose not to write it up here, and that is if angle 2 is 90 degrees, what else could you say? They're all 90. Okay, I just chose not to write that one. So that was all the stuff, and you guys did well. So we got the postulate 10, that's the corresponding ones. We got 3, 2, that's the alternate interior, they're congruent. Oh, by the way, corresponding angles congruent. We have 3, 3 that says same side interior supplementary. We have 3, 4, the one that I chose not to talk about, but if this one is 90, then they're all 90, right? Theorem 3, 4 actually says if L is perpendicular to T, then it's also perpendicular to N.
Well, all you have to do is say that they're 90. There is nothing
Okay,
more
all
to
right,
that.
I'm with you. All right. We had the fact that from now on, they're going to use these little triangle things to show that the two lines are parallel. They're not going to write that, right?
Well,
And the so what is that all of that information could be asked 3 different distinct ways. So now we're going to get to test questions. You ready? I can ask all of that stuff 3 different ways. So vanilla, strawberry, chocolate. So here's the vanilla way. The vanilla way is the easiest way. The vanilla way just says, find the value of a given angle, or of an angle, and I'm only going to give you degree measurements, no variables. It's the easiest one. So it's going to look something like this. I'm going to give you 2 things.
180
Right?
minus 70 equals.
So what you need to do, here's your 5 things. You need to look at the 2 things that are given and tell me what's the relationship between this angle and this angle. Go ahead.
The same side.
Same side interior. So same side. What do we know about the so what about same side?
Supplementary.
They're supplementary. Therefore, how big is the question mark?
180 minus 70.
Which is
110.
110. Okay. So 110. Yes. All right. Anna, I can make the picture more complicated. What can you tell me about these 2 angles? Because they are same side interior. So it's the same question. I just made the diagram more messy, right? So therefore the angle is, which is, how much? 30? Where are you getting a 30 from? What? 83 and 7, that is your common high school math student mistake because you're thinking 90 and 180 and you're forgetting which one is which. The 2 added is 90 or the 2 added is 180? So 7 and 83 is 90. Take a deep breath. What's the answer? Help her out. 73. 73 and 7 would be 180. Okay. Yes? All right, Allie, take a look at the picture. This is box number 2, or box number 1? Box number 1. What's the relationship between those 2 angles? Why? Don't overthink it. They make a straight line. They're adjacent. They make a straight line. Therefore, they are supplementary. Therefore, how big is the angle? How much? Yes or no?
Which means all the other side of that one is 81. The other side.
Which one is 81? Upper left or lower left?
Upper left.
Upper left is 81. Lower left is?
90.
Yeah.
Boom, I'm right. I survived.
All right, McKinley, you're on.
No. These are different. They're the last one. They're conversal. The angles, the lines are.
Look at the picture and look at the 2 angles.
They're congruent. Yes.
Why?
Because they're alt interior. No, they're alt exterior angles.
Well, 52 is not on the exterior.
They're corresponding.
Here are all your possibilities.
They're corresponding angles.
Corresponding means same side, same position.
Oh, no, they're vertical
Why are they vertical?
because they're vertical.
What do you look for when you hear the word vertical?
The other side of that
What do you
line.
look for when you hear the word vertical? What shape are you looking for when you hear the word vertical?
A triangle.
No. You're looking for that X.
Yes.
Do you see the X?
No. I guess it's a question mark.
Right there. There's the X. And vertical angles are what? Next to each other or opposite each other?
Opposite of each other.
And aren't these two angles opposite each other?
Yes.
Therefore, a question mark is how big?
They're congruent.
So therefore, question mark is how big?
52.
It is 52. That seemed very painful. Why are we still confused about vertical angles?
I'm not confused.
Okay.
I think that you say it.
Well, I had to walk you through that, walk you to that answer. All right, number 3, you're up. Let's go.
They're alternate interior.
Therefore,
It's 62.
why did I call you number 3? Because I saw a picture today. Inside joke. Okay, so how big is question mark?
62 degrees.
There you go. You should be. She understands. All right, and now she's going to kill her mom. All right.
Clearly 150.
You're on. Why? They're corresponding. Notice corresponding, same side. They're both on the right side of the transversal, same position. This is in the upper right. This one's in the upper right. They're congruent, therefore 105. Okay. We good on this? All right. I'm just going to say, I'm going to give you 26 of these to do. You get to determine whether or not you need to do 26 or not.
I'll do 4.
You need to do closer to 26 than 4. Seriously, I'm like, no joke. You need to do closer to 26 than you can do 4. Maybe Allie could do 4. Maybe Anna does 12. We'll call it good, right? But make darn sure, because before we go to the more challenging ones, that this is locked in your brain, like you have no doubt. Okay. All right. This is strawberry. What's the difference? I'm given a variable in each one, but the question is still the same, McKinley. What's the relationship between these two angles?
Sides, so they equal 180.
Okay, so what do you want me to write?
You add those two.
What do you want me to write?
26x minus 4 plus 20x equals 180.
Okay, sounds good to me. Can you do that one real quick?
46 plus 4 divide 46. Get your answer.
Okay, that's how it's done. You're on.
They're alternate interior.
Therefore,
They're congruent.
therefore,
It's 120.
keep talking.
So it would be 25x minus 5 equals 120.
And could you solve that? Do it.
25x equals 125. And 125 divided by 25.
Is
5.
I always think quarters. 4 quarters is a dollar, so 125. $1.75 would be how many quarters? Well, 8 would be $2, so it's got to be 7, right? All right, you're on. Therefore,
17x plus 6 equals 19x.
I asked period 1 or period 2 if they could do this in their head, and they were like, I don't know, it's too hard. So you got to do this in your head. Okay, so tell me what to write.
So 6 equals 2x minus 2.
Keep talking.
Plus 2, so 8 equals 2x minus 2, so it's 4.
And that's why you're in honors class, not in a regular class, right there. You can do that one in your head real quick. Cool? All right, so I'm giving you, I don't know, that math there hurts my head there. I'm going to give you a bunch of those, right, to do. What's the difference between the ones I just showed you and the ones we previously did?
They're bigger.
It's just variables thrown in. It's the same stuff though, right? So if you really put in, if you do 25 of the first ones or however many I gave you of that one, I mean, this one maybe you do 10 or 4 or something like this. Okay. But what's the one issue with this? What's this say is the answer?
X. 4.
Right. Is that how big the angle is?
No.
So what will we have to do?
Put it back into the.
Okay. So the last flavor, chocolate, right, is you're going to tell me how big the angle is. Now, this particular worksheet program generator thing has one that's kind of gray and one that's kind of dark.
Well, those two equal each other. Then
I
you
know,
get
but
the
hold on.
answer, then
They're
you
going
get
to ask you to figure out the dark one. Okay? So, McKinley, go. Tell me what to
the
do.
equal each
So
other.
tell me what to do.
2x plus 2 equals 13x minus 7.
Okay?
Then you change 2. You subtract 2 and then add and subtract.
We have variables on both sides. Do the variables before you do that because you don't know which side you got to move the constants
Yeah,
to.
I need to move the variable over there. Move the 2 over to the.
Which
other
one are you
side.
moving?
The 12.
Okay, so tell me what to write after you move the 12x.
So 13x minus 12x equals 1x.
So tell me what to write.
2 equals 1x minus 7. Then you add 7 to 2, which gives you 9, and then 9 equals x. Then you put it back in the 12x, and you get 108 plus 2, which gets you 110.
Good job, all by yourself. That was impressive. Cool. So, 9 of those to do. I didn't give you that many. Right, that's 10, sorry. 10 of those to do. Cool? All right. Last idea is this. It's the same question, but it's going to say, what value must the angle be to make the two lines parallel?
Well, that's easy. They just
Right.
never cross.
So if this is 119, how big does this have to be in order for them to be parallel? Well, what's the relationship between this angle and this angle?
Oh, they're alternate interior.
Therefore, if they're parallel, how big is this angle? What was the so what about?
Oh, they must be exactly the same.
First off, what's the name of these two angles? Here's your options.
Oh, they're corresponding.
So if they're corresponding, then this angle must be
119.
119.
But I
Okay.
already said that.
I know, but we're just explaining. All right. And this was your same question as last time that you got stuck on. So what's the answer this time? 72. Okay, 72. That's it. Nothing left. All right, I'm going to hand you a big honking packet somewhere right here. Do not panic. It's big and honking because, I got to draw the shape every single time. So it's not as bad as.
Well, then for every 4 questions, you put different types of answers on one giant line.
But I would encourage you for the first 20, what is it, 5 or 24? 26. For the first 26, I would do every one. Oh, by the way, the answers are on the back as well, too. To check your answers. Or not on the back, but you can rip this page out if you want to have it so it's next to you. Make sense? Jack, do you have any questions? Jack, why did I call Jack? Ben, any questions?
No, actually, yes, I have a question. Where can I get the worksheets?
Give me 1 second. I'll make it live right now.
Okay.
I usually make it live at 8 o'clock, but I'll make a special.
You can just include it on the homework.
Well, I'm just going to change it from going live at 8 o'clock to live at, say, 2 o'clock, and then you'll be able to see it right now.
Okay.
Oh, I don't want algebra. I want geometry. View number 1. Edits. 2 p.m. It only allows me to pick a time in the future, so I'm going to check. I'm going to select 2:30, so it'll be live in about 6 minutes, 4 minutes.
Okay.
All right, should be good to go.
Okay. Thank you.
All right. I'm going to stop the recording right now. We will catch you tomorrow.
Goodbye. Have a nice day.
You as well.